Hello, for this next lesson, it's called Triangle Inequalities. So what we are hoping you to do is expand on the definition of what is a triangle. So up to now, we've concentrated on that a triangle is a three-sided closed figure, and we know that the angles inside always total 180. Well, now that we've really worked on all the lessons on angles in a triangle and outside of a triangle, now let's move away from angles and degree measurements and let's talk about the sides. What actually makes the sides close? So I'd love for you to try this at home. If you don't, of course, you can just sit back and watch, but it really is helpful when a student can try this at home. And those in person, I'll be able to let you play with. I have some of these little plastic pieces. And so obviously, I know that most of you are not going to have any kind of little plastic pieces at home, such as this, unless you have a little brother or sister that might have some kind of little tinker toys or something along those lines. But pipe cleaners often work, toothpicks, cutting strips of paper, and even spaghetti noodles. And what you want to do is you want to make them be have some 1-inch ones, 2-inch ones, 3-inch ones, 4-inch ones, and 5-inch ones. So I would suggest you have 3 of each. So essentially you need 15 pieces. So you could take a spaghetti noodle and you could take one piece spaghetti noodle and break it up into 1-inch pieces. And you need 3 1-inch pieces. Then take a spaghetti noodle and make 3 2-inch pieces. And then make 3 3-inch. And then 3 4-inch and 3 5-inch pieces. Pipe cleaners also work. If you have a pipe cleaner, what I often do with pipe cleaner, I don't think I have any pipe cleaners here with me anymore. I used to have some already pre-made, but what I've done with a pipe cleaner is you just take a long piece of pipe cleaner and take a ruler, lay the ruler along the pipe cleaner, and mark off little 1-inch marks. And then what you do is you fold the pipe cleaner depending on how many pieces you have. Because what we want to identify is what makes a triangle and what doesn't. So with my little pieces of paper and my little measurements, I have some lengths already pre-made. So what I have is I have an orange. This is purple. The color is not really coming out well in the video. This is green, blue, yellow, and red. Sorry, I did them out of order there. And over here on the right-hand side, I've written how long each of mine are. Of course, the manufacturer didn't make them nice, round numbers. They did them in centimeters. I think they technically probably might be in inch measurements, but they're not quite even an inch. 2 3/4, 3 1/2. So they're not even nice measurements that way. But they've measured them out in centimeters. And so what I can do is I can put pieces together. And I have 3 of each color. So for instance, I can start and I can take 3 orange, and mine are nice and they snap together. That's the advantage of my geometric tools, that I can put them together. And I know that if I have an orange plus an orange plus an orange, I am going to get a triangle. Yes. So an orange is 5 centimeters. So a 5, 5, 5 is going to work. Now, if you're doing this at home and you're doing your spaghetti noodles, you can just write the 1s, the 2s, the 3s, the 4s. So if you did a 5-inch, a 5-inch, and a 5-inch, it should work if you use yours. Now, what I want you to be able to do is also find ones that don't work. So for instance, in this orange, 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 and you can do any combination you want as long as you pick 3 sides, I'm going to take one of these orange away, and I'm going to add a blue onto the end. Well, what happens when I have an orange, and a blue, you're going to see that it's impossible for me to make this connect without, and I can't even get it to snap well, maybe if I get it to go, you'll see that I can make this little bendy. And remember the warm-up the other day, we talked about you can't have bended sides. So if I have an orange, and a blue, it does not make a triangle. So orange was 5, and blue is 12.24. I don't get a triangle. So what I'd like you to do is take some time and try to figure out when you can make a triangle and when you can't make a triangle. They don't all have to, you don't have to have repeaters either. So for instance, I could take an orange plus a purple plus a red. And you tend to learn more from no's than you learn from yeses. A lot of times when you do all yeses, you start to make assumptions. And this is why we talk about counterexamples. Counterexamples teach you a lot. So anytime you get things that are no's, you'll learn more. So I have an orange, a purple, and a red. So my orange is 5, my purple is 7.07, and my red is 14.4, or 14.14, and that makes a no. But if I replace this orange with a green, now I get a nice triangle. So if I do purple and green and red, I get a yes. So my purple is 7.07, my green is 8.66, and my red is 14.14. So what I'm hoping for you to be able to figure out is a relationship among the lengths that's going to make a triangle. So try to fill out this chart, come up with, I usually recommend half of them being yeses and half of them being no's, trying to find ones that work. And then once you do that, try to make a theory. What can you see in this chart of what makes the triangle lengths work? And then once you do that, test your theory. Do you think these would make triangles? So if you had some nice whole numbers here, do you think if you had a 5-inch, a 4-inch, and a 2-inch piece of spaghetti noodle, does that make a triangle? And if you have those lengths in front of you, you can actually test it out. But then I get some really long ones over here, so that maybe you can't just test them out with your spaghetti noodles. So try to fill that out. I'm going to pause, you pause, and see how you do, and then come back and we'll reconvene. So I've done a few more rows. I haven't quite filled up my chart, but I've done quite a few more rows here. And so when I do these, if I look down, I have 1, 2, 3, 4, 5 no's and 1, 2, 3, 4, 5, 6 yeses so far. So like I said, I'm trying to keep it around 50-50 because that gives me some information. But what I want to now concentrate are the numbers. And even without thinking about the numbers, think about all those no's. One of the no's I want to draw your attention to is the orange, yellow. So the orange, yellow looks like this. And some people might think that this makes a triangle because they can kind of shimmy it a little bit. But really, it just makes a straight line. The two oranges together lay on top of the yellow, and it just makes a straight line. So that doesn't quite work. This orange, purple, blue one is interesting because I can almost snap it, but it has to make a little curve in there. So how can I describe what is happening here? Think about what can you say is happening. Why won't it close properly? And then, of course, when I replace that blue with a red, it really accentuates that it doesn't close. I can't even get this down there without doing a significant bend to my red. It kind of looks like a bow and arrow now. So what can I describe? And so take a minute, pause if you need be, think about what's happening, think about the numbers. So, what has to be true? So for instance here, when I had a 7.07, an 8.66, and a 14.14, I got yes. But when I had a 5, a 7.07, and a 14.14, I got a no. Think about the relationships in these numbers. What happens? Why did it work? So I had a 14.14 as my big one. I had 7.07 in both of these. But why didn't it work when it was 5, but it did work when it was 8.66? All I did was change orange to green, and it suddenly worked. So what happens? So what has to be true of the lengths? So let's talk about it. What has to be true? Many students each year say, well, it has to be able to stretch. It has to be long enough. It has to be able to fit that longest side. If it doesn't fit, for example, in my scenario here, that it lays equally, well, it's not going to allow you to make any kind of triangle out of it. It's not going to let you be able to pop it up and make an angle. I really like this one with the orange and the purple. I can't stretch it. It doesn't reach it without creating this bend. So it's just not long enough. So how can I put that into mathematical terms? what I would put into the mathematical terms is the two small sides, they need to be able to stretch to reach that third side. And how I can put that into math terms is if I add the two lengths of these small sides, it has to grow out to be long enough to reach. What number is long enough? It has to be more. Why can't it be equal? Well, if it equals, I get this. I get that flat line because my orange is 5 and my yellows are 10. So 2 5s equal a 10, but it doesn't allow me to truly make a triangle. There's a little bit of wiggle here, but it's not really making a triangle. There's bending happening to happen it. If these were all real stiff, you wouldn't even be able to do anything. They would just lay flat on top of one another. And I think you would notice that if you did it with your spaghetti noodles. If you did it with your spaghetti noodles, you would snap a spaghetti noodle trying to do it. So what has to be true of the lengths? The sum of the two smallest sides must be greater than the longest side. Oops, spelled longest wrong. Longest side. So when you start looking at numbers down here at the bottom, what you have to do is you have to say, all right, well, what's my longest side? So out of 5, 4, 2, my longest side is 5. If you take 4 and you add 2, is that more than 5? Yes. 4 plus 2 is greater than 5? Yes. My longest side is 21. If I take 8 plus 11, is that more than 21? 8 plus 11 is 19? No, it's not. Here, all three sides are equal. Anytime all three sides are equal, hopefully you notice when you're doing them, they're always going to work because it doesn't matter which side you pick as the smallest or as the longest side. So say I pick that 5 being the longest side. 5 plus 5 is definitely going to be more than 5. That's yes. Here, what's my longest side? My longest side is 7. 1 plus 5, is that more than 7? No, it's only 6. It's not going to stretch. Over here, longest side is 9. Is 4 plus 5 more than 9? No. Equal doesn't work. Equal isn't longer. It has to be longer. My longest side here is 130. Is 85 plus 96 more than 130? Yes. My longest side here is 87. Is 45 plus 63 more than 87? Yes. My longest side here is 143. Is 91 plus 47 more than 143? No. So the ones that should have come out to be triangles were number 1, number 3, number 6, and number 7. So at the top of the next page, I have it again in the actual mathematical terminology. So it says in order to form a triangle, the sum of the two smallest or shortest sides must be greater than the length of the longest side. And in truth, any two sides have to be longer than the third side, but it's really the relationship between the smallest and the longest side that has to be there. So with that, that is your triangle inequalities theorem. So now you're going to have some that you're just going to say yes or no. Do they make a triangle or do they not?